assignment which I gave. Okay. So let's see, starting with this problem here. See, first one, you notice the first, if you notice the first question, 15 grams of barium permanganate sample containing impurities completely reacting with 100 ml of H2O2. What will be the percentage purity of this one? Okay. This is a nice mix of, mole concept and redox. Check. So here, first we figure out what is the normality of H2O2. That would be equal to 11.2 divided by 5.6. If you recall the formula, molarity is equal to volume strength into, volume strength by 11.2, and normality is equal to volume strength by 5.6. So that is the same formula I have applied here. So that makes this normality as 2 normal. And then if you notice the milli equivalence of this one and milli equivalence of peroxide, they should be equal, right? So let us just equate that. So milli equivalence of barium permanganate MnO4 twice, that should be equal to milli equivalence of peroxide. So in this case, peroxide is having 2 normal into volume is taken as 100 ml, right? So that will make it 200 milli equivalence. And if it is 200 milli equivalence, then what will be the moles of, uh, for that, we need to check out what is the valency factor for this one, right? Now notice this part, MnO4 minus will give you Mn plus 2, correct? Mn plus 2, which means 5 electrons are transferred. So, but for one molecule of barium permanganate, there are two MnO4 minus, which means there should be 10 electrons transferred. So, valency factor of, the valency factor of barium permanganate will be equal to 10. Hence, number of moles of the barium salt here, MnO4, MnO4 twice, will be equal to milli equivalents divided by valency factor, which is equal to 200 divided by 10. So how much it is? 20 millimoles. So we got this as 20 millimoles here. Got it? So if it is 20 millimoles, what is the weight of this salt here? So weight of barium manganate permanganate will be equal to 0.02, which is moles, into millimoles have converted into moles, into molecular weight. Molecular weight of this one is 375. Don't worry, this will be given to you in the question. So that will be the total weight which is reacted, but the amount of the sample given is 15 grams. So the percentage purity is always equal to the weight of pure form divided by weight of sample into 100. So therefore that will be equal to 0.02 into 375 divided by 15 into 100. Okay. So that on solving, I was getting 50%. Okay. So that's how the percentage purity is coming out to be 50%. Okay. Very standard question. So I am hoping that all of you have understood this. So know how to solve it. Okay. Let us get to the next question here. Second question is relatively easy. I'm not touching that. Okay. Let us see the third question. Third question is interesting. Again, a mix of nice questions here. Check. See the third question, everybody. 105 ml of pure water at 4 degrees ammonia gas yields a solution of density 9.9 gram per ml and containing 30 percentage by mass. Find the volume of the resulting ammonia solution. Okay. Find 105 ml of pure water of this one when with ammonia gas, pure water with ammonia gas yields this one. Find the volume of resultant ammonia solution. Okay. Now here at 4 degrees is a hint to give that density of pure water at 4 degrees is 1 gram per ml. That is one thing you should recognize. So what is the weight of water in that case? Weight of H2O will be simply equal to 105 grams. Correct? If weight is this much, let us assume let weight of ammonia let weight of ammonia be equal to X. Clear? So now the given amount of moles will be equal to X amount divided by X plus 105. X plus 105, this is the total mass, into 100. This percentage is given as 30 because it is given as 30 percentage by mass. Correct? So that implies you solving for X, it is coming out to be, I think, 45, I guess. Yeah, 45 grams. So in this 105 plus 45 grams is the total amount of weight. So total weight is coming out to be 150 grams. So since it is 150 grams, what is the volume of solution now? Volume of solution will be total weight, total weight divided by density. So total weight is 150 divided by density of solution is already given to us, which is zero point 0.9, right? So that is coming out to be zero point 0.9. So therefore, this is coming out to be 166.6, ml. So that is the answer. Okay, clear? Again, very simple case, how to convert into various volume factors from mole concept. Next, check out the fifth one now. See, volume V1 of K2Cr2O7 is needed for complete oxidation of N2H4 in acidic medium. Now, the volume of KMnO4 needed for same oxidation state in acidic medium is how much? Okay. So we can assume that this N2H4 is getting oxidized to some kind of oxidation. We don't know what it is, but we can take it as N2. Okay. So therefore, imagine like this Cr2O7 2 minus plus N2H4 must be giving Cr plus 3 because this is usually in acidic medium, and nitrogen is getting oxidized to something. We are not sure about it, but usually it always happens to be N2. Okay, but sometimes it might be given NH2OH or something. So check. This is happening. So we can say that since if you notice the equivalence of chromate Cr2O7 2 minus, that should be same as the equivalence of hydrazine. And since the hydrazine has same number of equivalents that is to be drawn, so I can say that the equivalence of KMnO4 when you react with N2H4 should also be same as the equivalence of N2H4, correct? Which means this should be equal to equivalence of Cr2O7 2 minus. Okay. And you know that KMnO4 generally when it is getting reduced in the acidic medium will convert into Mn plus 2. So therefore, now I require to calculate what is the volume. So see, volume into molarity into valency factor of KMnO4 must be equal to volume into molarity into valency factor of Cr2O7 2 minus. So valency factor into molarity is given here as 0.3. Valency factor of KMnO4 is 5. While volume of K2Cr2O7 given is V1 and molarity given is 0.1 and valency factor is 6. So therefore V is equal to V1 into this will become 5 into 6 by 6, this 6 by 3 into 5 here. So therefore V1 this will go 2 times, so into 2 by 5. So 2 by 5 times of V1 is your final answer. Okay, here please check this. So I guess all of you got that. Done. Next. Ninth one is easy. 10th one is also easy, straightforward. I mean, just the poly basic acid, you should be able to figure out that. See 11th one. N2SO3 is standardized iodometrically against KBrO3. This process requires 45 ml of hypo. What will be the molarity of Na2S2O3? Okay. So let us see this here. What I can say, S2O3 2 minus here plus BrO3 minus. Correct. Since it is doing iodometrically, which means it should be changing similar to that of iodine. So in that case, iodine gets oxidized to I minus. So BrO3 minus should also be getting oxidized to Br minus. And on the other hand, this should become S4O6 2 minus. Correct? This is what has been expected. Now, if you notice the number of moles that are being changing from here to here, so by balancing it, you know that there will be two electrons transferring from here to here, while from here to here, if you notice, sorry, not two electrons, my mistake. Here it will be plus 4 for 2 moles, yeah. S2O3 2 minus, if you take for 2 moles here, it will be plus 4. Here for 2 moles, it is plus 5. And that will be 2 moles for 4 moles. So 4 moles of sulfur versus 4 moles of sulfur, if you compare, 2 electrons have been transferred. And 1 bromine will transfer 6 electrons here. So if I balance it, I would get this as 6 times of 6 times of S2O3 2 minus plus BrO3 minus. That should be giving Br minus plus 6, not 6. Yeah, 3 times. So 3 times of S4O6 2 minus. Yeah, this is what it should be. Now, based on this, you can solve the question given. The weight of the KBrO3 minus is given, and this process requires this much amount of hypo. What is the molarity given? So, notice this one. 6 moles require 1 mole. Molarity is M. M into 45 requires how many moles? So, M into 45 divided by 6 here. That should be equal to millimoles of KBrO3. And how much is the millimole? 0.1262 into 10 raised to power of 3 divided by molar mass. Okay. The molar mass of KBrO3, if you compare, let me write down that molar mass here. How much it is? 39 plus 39 plus 80 plus 48. So 167. So that is coming out to be 167 here. So therefore, if you notice, M should be equal to 6 into 0. Or let me write this as simply 126.2 into that's it, that divided by 167 into 45. Got it? So 6 into 126.2 divided by 167 divided by 45. So that is coming out to be zero point 0.1 exactly, zero point 0.1 molar. So this is coming out to be 0 0.1 molar. Done. Please make a note of it. I mean, check it out. Don't worry about writing, just check it out how we have solved it. Here on this 11th question, everybody. Let us see the next one. 12th one is not a big deal. You should be able to figure out. It is in a similar lines. Okay. 25 ml of this one. 13. H2SO4. 13 also is not anything different. Very similar one. Okay. Check out this 14th one. I'll just give you a hint of it because it is again a similar one, but this is very frequent. This is more, mains driven question. See, how is it? Basically, we have KiO3 plus Ki, and this will undergo calm proportionation to I2 and H2. As long as you are aware of that, uh, you should be able to get the point here. Okay, not H2O but K2O, because potassium is becoming K2O part here. Okay, so it is a calm proportionation of IO3 minus plus I minus is giving I2. So that's it. You use that value, use that number of moles part, identify which is limiting. Based on that, you can figure out, what is the weight. All right, that is one easy way. Let's check out 15th one. Yeah, this was important, guys. Please check out back titration. One important question from back titration, which is Geldahl's, how it works in Geldahl's method. See, Geldahl's method is about uh, extracting nitrogen in the form of ammonia from an organic compound. Okay, any organic compound, when you react with, when you react with H2SO4 here, if there is any amount of nitrogen in it, it will convert into NH4 plus ammonia, and that will come out. Got it? Right? Just a second. Sorry, guys. Check. See, zero point 0.7 of the organic mixture, right, which contains, sorry, he's directly given the compound here. Zero point 0.7 mixture of this one was boiled with 100 ml of 0.2 normal NaOH when all the ammonia evolves and get dissolved in solution itself. The remaining solution was diluted to 250 ml. 25 ml of this solution was neutralized using 10 ml of 0.1 molar H2SO4. What is the percentage purity of this one? Got it? So first, do it in a reverse way, that if this much amount of solution was used here, just a second. Sorry guys, check. So we have 25 ml of this solution was neutralized with 10 ml of 0.1 normal H2SO4. Got it? So now if you notice this, milli equivalence of ammonia, right, which milli equivalence of ammonia in this case, which is required to get neutralized here, this much, will be equal to how much here? See, think this way. We require 2 NH4 plus, correct, to neutralize this as 2 moles of NaOH here, isn't it? So which means if you have 100 into 0.2, okay, milli equivalents of till the ammonia get evolved. Yeah, whatever the ammonia which is getting evolved here, for that the milli equivalents of ammonia will be equal to how much? This 100 into 0.2, 100 into 0.2, right, which is 20 here, and millimoles of ammonia, millimoles of ammonia will be equal to how much? Millimoles of ammonia will be equal to 20 divided by 1, because valency factor is 1 for ammonia. But how much will be the millimoles of ammonium sulfate? Because here there are 2 moles of it, so it will be 20 by 2. So it will be 10 millimoles. Okay. So it will be 10 millimoles of it. Correct. And the remaining amount was diluted to 250 ml. Okay. And then 25 ml of this one. It may be diluted, but the number of moles will remain the same. So 25 ml of this was neutralized by 10 ml of this one. So let me write on that. 25 of H2SO4, 25 of what do you say, ammonium sulfate, correct? No, sorry, my mistake. One second. Let me rewrite this. Yeah. See, first let us calculate the total amount of total amount of NaOH that was used. Right? Total amount of NaOH used was 100 into zero point 0.2, which is 20 milli equivalents. Out of that, right, excess amount of NaOH which was later neutralized was how much? 10 into zero point 0.1. Okay, 10 into zero point 0.1. So that makes it 1, no, no, 25. 25 ml of this solution was neutralized with 10 ml of 0.1 H2SO4. Yeah, see. So if it is 10 ml of 0.2 H2SO4, so which means whatever the NaOH which was left over, 2 moles plus H2SO4, that is being converted into Na2SO4 plus H2. So in that case, this value is given as 10 into 0.1 milli equivalents. So the same milli equivalent should be present for NaOH also. So milli equivalents of NaOH that was used here will be 10 into 10 into 0.1. So 1 milli equivalent. So 1 milli equivalent was used from 25 ml. But for 250 ml, how much it was? Because it was diluted to 250 ml, correct? So 25 ml contains 1 milli equivalent of NaOH. So 250 ml will contain how much? 250 ml contains, okay, 10 milli equivalents. 10 milli equivalents of NaOH, okay? So could you imagine out of 20, 10 milli equivalents were used for this excess part. So how much was actually reacted with ammonium sulfate? Only 10 milli equivalents was utilized. Okay, so now I can write down that as milli equivalents of ammonia used for neutralizing with NaOH is same as milli equivalents of NaOH that is equal to 10 milli equivalents. 20 minus 10. 20 minus 10, which is 10 milli equivalents. Okay. So now the milli equivalents of ammonia is known. So milli equivalents of ammonium, milli equivalents of ammonium sulfate will be equal to how much? Okay. 10 by 2. So that is equal to 5 milli equivalents. Correct? Why? Because the valency factor this time is 2. Correct. So what will be the weight of ammonium sulfate here, beta? So ammonium sulfate will be equal to 5 divided by 1000 into 132, which is the molar mass. Got it? So 5 into divided by 1000 is for millimoles. Correct? So converting that into, this is millimoles, sorry, millimoles. Yeah. Right. So 5 divided by 1000 into 132. So that will come out to be 0.66 grams. So this much is the weight of ammonium sulfate in grams. So what is the percentage amount of uh, ammonium sulfate? Correct. That will be equal to 0.66 by zero point 0.7, which is given into 100. So that is approximately 94 percentage. That is around 94 percentage. Okay. Please check it out. Back titration questions are usually framed this way. Done? Yeah. Next. 15th, 16th. 16th is just a basic indicator form. 17th hypo question, straightforward question. 18th equivalence, you need to just express that. 19th, I mean, first one here. First one is again very similar one. You just need to check out MnO4 minus, how many moles with Fe plus 2, same with chromium and all. So this is not. I think this we discussed already. The other day we discussed about Cu2s and Cu2s with MnO4 and this. Okay. Mm, Next, what we could discuss here is, mm, we can discuss the second one. See, second one has all the variety of it. So, which of the following statements are correct? Equivalent weight of Br3O8 is 23. So we need to just check out which are the options more valid in this case. See, first one. How do we get to know the equivalent weight here? First, we need to check out how many number of uh, moles are been present in terms of bromine here. Here, what is the total charge? And that will be the valency factor. See, Br3O8, if you notice, we have three types of Br here. Br, and Br. I mean, two types of Br here. Bistructure. This is how the Br3O8 will be. Now, the oxidation state here is plus 6. Oxidation state here is plus 4. Correct? And here also it is plus 6. Got it? So, if you notice that this entire thing is converting into Br2, which is 0. Br2 is 0. Correct? So, if I put this as 3 by 2 Br here, so total charge of Br for 3 bromines here is how much? For 3 bromines here is uh, 12 plus 4. 12 plus 4, 16. 16 and here it is 0. So the difference in number of electrons is 16. So therefore, valency factor of Br2, Br3O8 is 16. So what will be the equivalent weight now? Equivalent weight will be molecular weight by 16. Got it? Molecular weight by 16. Molecular weight is how much? Molecular weight is 368. That is divided by 16, which is coming out to be 23. So the first part is correct. So it will be equivalent mass will be 23. Next, in case of oxalic acid, the average oxidation number and the individual oxidation number of carbon has the same value. Okay, that is true because H2C2O4, if you notice by structure also, C double bond O, OH and C double bond O, OH. Now check out here. This carbon is losing plus 2 here, losing plus 1 here, and losing 0 here. So which means the total charge is plus 3. Same logic goes for here. This is plus 3. This is the oxidation state. Oxidation number means average. Average, how do we calculate? 2x minus 4, not minus 4. How many oxygens we have? 4 oxygens. So minus 4 into 2 and plus 2 equal to 0. So 2x is equal to 6 and x is equal to 3. So you can see oxidation number as well as oxidation states are same. And that is what is the question asked. So in this case, this is also correct. Next, C part is in case of iodimetric titrations. Ki is made to react with oxidizing agent and then liberated iodine is made to titrate with hypo. Okay. Now let me again remind you the difference. Do means indirect reaction. Iod means direct. Clear? So remember, first generating I2. Suppose if you have something like a copper 2 plus and then you reacted with I minus, then you generated some amount of I2, then you treated with Na2S2O3. Then this is iodo. If you have directly I2 present in the solution and then you are reacting that with Na2S2O3, then this is IOD. So IOD and iodo has this difference. So this one is incorrect. C is incorrect. Next, equivalent mass of cupric phosphate. Okay, Cu3P. No, that means it is cuprous. Cuprous phosphate is given this way. What should be the case? Check. Right. Notice this. Suppose if you have copper, there are 3 moles of copper plus converting into 3 moles of copper 2 plus. Okay. So plus 3 changing to plus 6. So 3 electrons are transferred here. And there is one phosphorus which is minus 3 changing to H2PO4 minus. Here oxidation state is plus 5. So minus 3 to plus 5, the number of electrons transferred are 8. So total electrons transferred, because all of them are oxidation electrons, are 11. So what will be the valency factor? Valency factor is 11. So equivalent weight will be equal to molecular weight by 11. So that is also correct. So D is correct. Okay. Please check the question to everyone. I hope all of you got that. Done. Okay. Let us discuss this one question on hard water. Notice this. Calcium and magnesium is from 10 raised to power of 5 liter sample of hard water and quantitatively precipitated as carbonates, and weights of precipitate obtained was 568 and precipitate lost 264 of weight on strong heating. Okay, degree of hardness is 4 ppm and molarity of calcium magnesium ions in hard water is given and sum of molarity we need to figure out. Chalo, let us see this how we can solve it. Okay. See, first calcium is converted into calcium carbonate and magnesium carbonate. These are the two forms which it has. Okay. Overall sample water where it was present originally was 10 raised to power of 5 liters. So the volume is 10 raised to power of 5 liters initially. Okay, of hard water. Next, calcium carbonate, if you notice, let us call this as X grams here. If this is X grams, Total weight of the carbonates is 568. So this will be 568 minus X grams here. Got it? And it has lost some amount of weight here. What will be the weight it will be losing out to? Calcium carbonate will be converting into calcium oxide plus carbon dioxide on heating. MgCO3 on heating also will become MgO plus CO2. So the lost weight is of carbon dioxide only. The lost weight is of carbon dioxide only. And he said that this much weight is lost. So this much amount of carbon dioxide is formed. See, if you notice this one, the number of moles here, if you notice, acha, if I write in terms of moles, it is x by 100 and number of moles here is 568 minus x by molar mass. Molar mass here is 84. These are the number of moles. Okay. So now if you notice that 1 mole is losing out 1 mole of carbon dioxide. So this is also losing out 1 mole of carbon dioxide. So number of moles of carbon dioxide will be equal to x by 100 plus 568 minus x by 84. These are the number of moles of uh, uh, carbon dioxide. Okay. So weight of carbon dioxide will be equal to x by 100 plus 568 minus x by 84 into 44, which is the molar mass. And that should be equal to 264. That is what has been given to us. Clear? So from here, if you calculate what is the value of x is coming out to be 400. So 400 grams. So originally, calcium carbonate was 400 grams. Okay. So if calcium carbonate was 400 grams, then how much will be the weight of, what do you say? Yeah. How much will be the weight of this one? Magnesium carbonate. So magnesium carbonate weight will be equal to 568 minus 400. So 168 grams. Okay. Now figure out how many moles we have. 400 by 100 is the moles of this one. And number of moles is 168 by 84. Correct? Which is 2 times. So this one is 4 times. So total how many moles beta? 6 moles are there. 6 moles are there which is giving hardness. So what is the weight of calcium carbonate equivalent to this? 6 moles into 100. So which is equal to 600 grams. So what will be the degree of hardness? Degree of hardness is weight of calcium carbonate by the total weight or volume into 10 raised to power of 6. So that is 600 divided by 10 raised to power of 5 into 10 raised to power of 6, because the volume given is I think 10 raised to power of 5, I guess. Right, this is 10 raised to power of 5 or exactly. Yeah, 5. So 10 raised to power of 5. So that means this will get cancelled. So what it is 6000 ppm. So the answer should have been 6000 ppm. Clear? So is it given the same? No, it is given 4. 4. 4 is not correct. Okay. This one is not correct. Next. Molarity of calcium 2 plus ions in hard water is 4 into 10 raised to power of minus 5. Okay. Number of moles present for calcium is 4. So if it is 4 moles, so what will be the concentration here? Concentration of calcium 2 plus will be equal to 4 divided by volume. Volume is how much? 10 raised to power of 5. So 4 into 10 raised to power of minus 5. So yes, this one is correct. This one is correct. Clear? Understood? Sorry. Here it is not 6000 beta. I forgot that this is in liters. So 10 raised to power of 3 I have to multiply. So only 6 ppm. Yeah, 6 ppm. Next, about magnesium. If you notice magnesium, how much we have? Mg2 plus. Correct. Number of moles is 2. So 2 moles here. So 2 divided by 2 divided by same volume, 10 raised to power of 5. So 2 into 10 raised to power of minus 5. So this is also incorrect. So C is also incorrect. Next. Sum of molarity is 6 into 10 raised to power of minus 5. Correct. Sum of this is 6 into 10 raised to power of minus 5. That is correct. So D is correct here. Okay. Please check it out, everybody. Fourth question. Done. Right. See the next one. Fifth one, again, it is a similar one. Not going to that. Sixth one is a regular balancing one. Seventh one, chalo, oleum case is there. So let us do this oleum case here. Fuming H2SO4 is a homogeneous mixture of H2SO4 and SO3. In which of the following statements is correct? If H2SO4 and SO3 is homogeneous mixture of H2SO3, is it given? If H2SO4 and SO3 in is a homogeneous mixture of H2SO4 and SO3, then which of the following is correct? Sorry. I think A got the same this thing. So something wrong with the A part here. So remove that. Let's check out B here. If H2SO4 and SO3 are having equal masses in the oleum sample, the strength of oleum sample may be less than 100. Okay. These options got it wrong, beta. Think forget about this part. Just remember the statement is like this. Up to this part, the statement is. See, if H2SO4 and SO3 are of equal amounts, then what will be the strength of sample and strength of oleum may be less than 100. Okay, strength of oleum may be less than 100. Is it correct or not? See, if this is A and A grams here, weight of oleum has to be 100 grams. So it has to be 100 grams. Then only we can define the strength for that. So which means this has to be 50 grams, this has to be 50 grams. Clear? So strength of oleum will be always expressed as 100 and above, because for 100 this much amount of SO3 is present. So percentage amount of water that need to be added is what we need to check, right? How much is the percent? How much is the amount weight of H2O that need to be added? So H2O that need to be added by formula is 80 by 18 into, sorry, 18 by 80, 18 by 80 into weight of SO3, which is 50, correct? So 18 into 5 by 50 by 8, correct? So this much is the percentage that need to be added. Okay, then only we will get this. So I think this is coming close to how much? 18 fives here. So 18 fives, 40, 90. Okay, so 80. So 10, 11, approximately 11.2 something. So what should be the percentage now? 111.2 percentage. That's how we have to write. So this one is an incorrect option. The strength of oleum is 100 plus percentage. Then the X of the is the added to 100 grams whole sample to convert SO3. That is correct. So this option is correct. Okay. Other options got a little jumbled. So, but I think these two options, you know. Next one. Yeah, this eighth one is a very standard mole concept question. So check it out. How do we figure out these kind of questions here? If 100 ml of 1 molar H2SO4 is mixed with 100 ml of 98% by weight, density is given, then what happens to the concentration? See, these are very simple ones, but while solving questions, we often forgets one or the other factor here. Check out first one. There are two samples. One is M1 molarity is 1 and V1 is 100. Okay. So the number of moles in this case is N1, which is M1V1, which is equal to 100 millimoles. On the other hand, what we have is M2, which can be calculated as percentage weight by weight into density into 100, density into 10 divided by molar mass, which is 90. So this is 98 by 98 into zero point 0.1 into 10. So that makes it 1 molar. So here molarity is 1 and volume is also 100. So basically you are adding same molarity and same volume in both of them, isn't it? Same molarity and same volume. So will that concentration change? No, it will be remain same. Volume of the solution becomes double. That is true. There is no change there. Mass of H2O4 in the H2SO4 in the solution is 98. Well, if it is 1 molar and this much, so number of moles is 100 millimole. So weight will be equal to 100 millimole into 98 into 10 raised to power of minus 3. So that makes it how much? 9.8 grams. So total weight of H2SO4 will be 9.8 grams into 2. So that is the total weight. So C is incorrect. So mass of H2O is 19.6. That is correct. So D is correct. Okay. It's very simple question, but usually we get to do these mistakes. So check it out. Any doubt there? Next. See this ninth one, no? Ninth one is completely oleum based question. An oleum sample was labeled as 104.5% in 10 grams of this. Okay. In 10 grams of this sample, 90 milligrams is added. Then which of the following is correct in this case? Okay. See here we know that 104.5% represents we have added 4.5 grams. 100 grams is of oleum and 4.5 grams is of water, is of H2O. Okay. So therefore, 10 gram sample, 10 gram sample will have how much? 0.45 grams. 0.45 grams of H2O to be added. So SO3 plus H2O converting into H2SO4. Suppose if this was only 4.45 grams added. Sorry. So which means number of moles will be 0.45 divided by 18. And here this will be weight by 80. So if I equate this, I'll get weight is equal to 80 by 18 into 0.45. And that is coming out to be 2 grams. So basically SO3 is 2 grams here now. Okay. Next. 90 grams. So, for this again you are adding 90 grams of H2O. Sorry, 90 milligrams. 90 milligrams. So weight of H2O further added, weight of H2O further added is 0.09 grams. Okay, we got 0.09 grams, which will react with the rest of the sulfate which is present here. Correct. So therefore, how much amount of uh, SO3 was free already, right? Hmm. So this much amount of 0.09 grams has been present here. So that has been added. So 0.2 plus H2O here. So that will convert into H2SO4. The free amount of SO2, which is present for 0.45 grams, SO3, free amount of SO3, which is present, is 2 grams. I think but 2 grams was already used, right? 10 grams sample. 10 grams of the sample. Oh, okay, okay. 10 grams of sample means we have uh, 10 grams of this sample, correct? So this much amount of water was supposed to be used, but sorry, 0.45 grams of water was supposed to be used, but only we are using how much? 0.09 grams. So 0.09 grams was used here. Okay. So obviously this is the limiting reagent now. So 0.09 divided by 18 right? So 1 mole requires 1 mole. So 2 minus 0.09 by 18 is the amount that is getting reacted to form 0.09 by 18 moles of H2SO4. So in this case, how much is the weight of H2SO4 now? Weight of H2SO4 will be equal to 0.09 by 18, that into 98. This is the weight of H2SO4. Okay. So weight of H2SO4 in this case, because this will not remain, only H2SO4 will remain here. So that is coming out to be 0.49 grams. 0.49 grams. So weight is 0.49 grams here. And if out of 10 ml, listen everybody, out of 10 ml, 10 grams, if 2 grams is of SO3, what is the weight of H2SO4? Weight of H2SO4 in the original sample is 8 grams. So total weight of H2SO4 will be equal to 8.49 grams. This much is the weight of H2SO4. Got it? Now go with the options and see. So C option is matching. And what are the other options here? Solution contains 10.09 grams of H2SO4. Correct. We have added that much, only zero point 0.9 grams of H2SO4 we have added. So that will be the total weight here. Right. No, no. We have added SO3 also, no? SO3 of 2 grams. So 12.9. That is 10 and 0.09 we have added. So A is correct only. Correct. A is correct. Okay. Next. What is the percentage SO3? Solution contains free SO3. Acha, how much amount of SO3 is left? That also we need to find. One of the options are given. So here, if you notice, this is coming out to be 0.4. So weight of SO3 is leftover is 1.6 grams. So what is the percentage amount of SO3 present here? So 1.6 grams divided by total weight. Total weight is how much? 8.49 grams of H2SO4 plus 1.6 grams of SO3. That into 100. So this is coming out as 15.8 percentage. So 15.8 percentage, yeah, B. That is another option we should. Correct.
Sir,
So these are,
sir, can you explain again why A and C both are correct?
solution contains 8.49 grams of H2SO4, right, beta? And how much is left over, beta? 1.6 is left. So how much, if you add it, what is the total amount we are getting?
10.09.
So 10.09. Acha, sorry. I thought it is sample beta, sorry. Yeah, A will not be correct.
Okay, okay.
H2SO4 is given, sorry. I thought it is sample. Okay. Only total solution sample weight is 10.09. Only H2SO4 is this much. Right. Thank you. Please check it out, everybody. What is the next one? 3 minus soon is easy. Length one you can do it. Oxidation state questions, I think you should be able to apply the coefficient of this. Okay. Check out on paragraph 2 here. Basically, it is question related to principle of atom conservation. Usually, if you want to conserve any atom here, in this case, suppose if you are conserving the number of moles of POC for ABC. So if you notice the number of moles of A here, so applying for POC for ABC here, how much it is, and X is equal to number of moles of X. Okay, this entire paragraph is just explaining POAC. We don't have to worry about that. Directly check out the question here. Okay, check out the fourth question now. Which of the following relationship regarding the numerical coefficients P, Q, R can be balanced out easily? Okay, not easy. Suppose if I have to conserve A, I have to conserve A, isn't it? So what I could say about conservation of A here? So I could say that in this molecule there is only one A present here, isn't it? And remember, when it comes to coefficients here, to balance this coefficients, first, because this value is already given to us, we can directly do this. A2B5 is given here. So Q will be equal to 5 by 2. That is one we can use. And P is equal to 2R. Correct? So that is a relation we could already have. Okay. Now what I could say, number of particles of A into 1, because A has only one A. That must be equal to number of particles of A2B5 A2B5 multiplied by 2. Why? Because number of particles of A2B5 will have two times of A. So this is a POAC, POAC for A. Correct. Similarly, if you apply POAC for B, what do I get? I'll get number of moles of uh, B, B2, number of moles of B2 into 2 must be equal to number of moles of A2 B5 into 5. That should be the case here. So now if you divide these two, what do I get? I'll get Na by NB2 is equal to 2 by 5. So which means Na by 4, sorry, Na by, sorry, this is 2 here. Na by 4 is equal to NB2 by 5. NB2 by 5, isn't it? And if you notice this is NB2 by 5, so NB2 by 5 will be equal to, if I take this as 5, this 2 can go here. So that means it will be equal to N A2B5 by 2 also. And A2B5 by 2 also. Okay. So when you get this coefficient, right, we can directly write that as when you get these values, right, where you are able to relate all the moles in terms of their ratios with the coefficients, then we can directly write them as the values here. So 4A plus 5B2 is giving 2 times of A2B5. That's it. So this is the overall equation. So now you know how to relate with the P, Q, R and all of that. Done? Clear everybody how to relate this? Let's notice the next question here. Check out fifth one. On a similar terms, I have fifth question. If the weight of C and O2 is present in 1 is to 2 and both the reactants completely consume and form CO and CO2, we will obtain a gaseous mixture of CO and CO2. What will be the weight of CO and CO2 in the mixture? Okay, weight is in the ratio of 1 is to 2. Okay, so basically we have C plus O2. One equation is giving CO, other one is C plus O2. The other equation is giving CO2. So here it should be half. Okay. So here the weight, if at all, it is W1 and W2, correct? And here we have this as W2. Sorry, here we have O1 and O2. Let's say O1 and O2. So let me write PP. Okay. So this is P1 and P2. So all we know that the weight ratio W1 plus W2, this is the total weight, that divided by, okay, P1 plus P2. is equal to 1 by 2. This is one ratio we know. Got it? No, sorry. I don't think he has given it in terms of two different reactions because he didn't give anything about percentage weight distribution. Okay, which means within the same reaction, beta, it is giving carbon monoxide also and carbon dioxide also. That's why we are not able to decide how many, what should be the ratio here, correct? So to get this, because we are not sure about how much ratio it is, and since C and O2 are completely consumed, we can apply POAC. That's why he's using this question for POAC kind. Check. So what do we know here is that if the weight of weight of carbon, let us write it as W, then this should have been 2W. Got it? Now let's say before the reaction, after the reaction, nothing will be left. Got it? And let this be amount as P here, correct? And Q here. This is the amounts which are been forming. Got it? So what we could say here is that if we apply POAC in both the cases, I can write this as 1 into number of moles of carbon must be equal to 1 into number of moles of carbon monoxide plus 1 into number of moles of carbon dioxide. So number of moles of carbon should be same as number of moles of carbon monoxide plus number of moles of carbon dioxide, which is W by 12 must be equal to P grams. This is in grams. Everything is in grams. Okay. So P grams by, this is 16 plus 12, 28 plus Q by 44. This is equation 1. Correct. Similarly, if you notice the same thing for O2 conservation, what we can write? 2 times of number of moles of O2 is equal to 1 time of number of moles of CO plus 2 times of number of moles of CO2. Correct. If I write in terms of weights, that will be equal to 2W divided by 16, sorry, divided by 32 is equal to P by 28 plus 2 times of Q by 44. 2 times of P by 44 here. Got it? So not N here, 2. 2 times of. Okay. Clear? So from here, if you notice this, directly I can uh, take a ratio of 1 is to 2. I mean, if at all I divide 1 by 2, W will get cancelled. I will only have terms P and Q. Okay. So eventually when you do that, P by Q ratio is coming out to be 7 by 11, it seems. So 7 by 11. Yeah, this one. Please check it out. Very good question. How to relate with POAC. Please check. And everybody. Done. Check. Sixth is relatively easy one. And next, these are uh, Olymp based questions are very similar ones, and I think molality, I'm sure you can do without formulas also. You should be able to use this and calculate. Okay, right. Please try rest of the questions, everybody. If you have any issue in a particular question, please put me a message. Got it? If you want, I can write the solution and send it to you. Okay. But meanwhile, please touch the variety. Okay, I hope you understood how we are trying to figure out different types of questions, how to solve them. Okay. So please touch more on the variety of the questions. If a lot of students who has asked doubts, okay,